Ladies and gentlemen, my name is Jeremy Champa. We're going to be looking at some questions from the non-calculator section of practice test 7. Let's jump right in. Okay, so appropriately we're starting test 7 on number 7. Of course you can do this question in a very traditional way, and I'll remind you that it's always good to do this question before you listen to my explanation. Give yourself a shot at the question. And if you already have, let's jump right in. Okay, so I'm going to think about this question in terms of dividing it into components and conquering those individual components. In each case, of course, we're going to get x squared. But let's first just think about how to get positive 4. Like, I can already see that I'm going to get 3 squared, which is 9, plus 5. That's not going to work out. So this is another 9 minus 5. That's going to work. This is going to turn into positive 9 plus 5 is not going to work. This one's going to turn into positive 9 minus 5, which is perfect. So we've gotten rid of 2 answers. To be clear about what I just said, I'm taking advantage of the fact that the middle term may be confusing when I square something like x plus 3. But the first term and the last term are easy. It's x squared and it's 9. Right? And even if it's x minus 3, it's exactly the same a and b terms. So now that I'm describing it all this way, you're like, well, why not just do it out? You totally could. But my point is that oftentimes in the SAT, it's good to have smaller checkpoints than just, do I have the full answer? Right? So ultimately, I have to get to a positive 6x. Well, there's no way that by multiplying negative 3x times, or negative 3 times x twice, we're getting positive 6x. So it must be the one with a positive 3. So that's the way I would do this question. Now, if you do it in the traditional way, which is to literally just FOIL this out, make sure you write it out because it's important to be able to FOIL these. And look, that would just be using the answer choices. So you'd really be doing the same thing. Because here's the deal. These answer choices are not like the normal way you would probably think about factoring x squared plus 6x plus 4. So because they're in and of themselves unorthodox answers, using those answers from the get-go was sort of necessary either way. And while you could just do the foiling, to me, I'd rather divide an answer up into components, and I'd look for those components to either work or not work. That way, I'm doing things, I'm like actively anticipating the fact that the mistakes are going to occur, by doing things in the traditional way, which is to say, like, do you forget to write out that x plus 3 quantity squared has a middle term like 6x? Anyways, we'll keep moving here. That was number 7. Feel free to ask me any questions you have about that one. In the meantime, we will jump to number 8. And this is a word problem. I would suggest starting at the end with the last sentence because all this earlier information is great in reference to what we're actually asked. But when we start with that earlier information, we're likely to drop some of the key pieces by the time we get to the end and have to reread it anyways. We're also likely to not know how to use that information. So I want to be able to use it the first time I see that information come up. So we want to know the smallest amount of hours. Notice I just said that in my own words so that I'm actively translating, so I really feel like I understand the question as quickly as possible. Absorbing information is about translating that information and being able to use it, right? So the smallest number of hours you can work to save at least $270 for the week. Seems like a case where I would probably just start by using my values. Now, I guess here's the deal. The smallest number of hours you could use. I'm going to start with one of the middle numbers. I mean, if 33 works, then that's cool. Let's just start there. He earns, so I'm going to read the rest of this now. So we're seeing, does he have to work 33 hours to make this much money? He earns $8 an hour for the first 10 hours. Okay, so let's extract and use that right away. $8, 10 hours times dollars. And that's going to equal $80. So no matter what, for the first 10 hours, that's what he makes. Now he gets a raise because he's doing such a good job. So now he's at $10 per hour. So I'll write that here. And we want to know for the rest of the week. Well, if he did 33 hours, let's just see what happens for those other 23 hours. Right, so that's $230. Now look, that means his grand total would be $310. right? His $80 plus his 230. He needs to save 270, and then this last bit of information. He's saving 90%. Okay, well, look, I know what 10% is, so I can just deduct that. Right, 10% is just 31. So what does that get us to? That gets us to 200 and I guess $81? Or $89? No, 279. My apologies. 279. 270 and 30 would be 300. 9 and 1 would be another 10. So 279. Okay, well, look, I actually am done here. Because 33 worked. And so I know that 38's not the least number of hours he can work. Also, it's only like $9. So these extra 11 hours that he's working is like $110, right? Like the difference between the 33 hours and the 22 hours is 11 hours at $10 an hour, right? Any of these other hours on top of the first 10, he's making $10 an hour. So $110. That's going to be a bigger difference than $9. So I'm done. Answer choice B. Right? That's the best way to do this question. Notice that I really didn't need to read the question twice because I was reading each sentence with an active purpose, right? I started with what am I asked? I looked at the answer choices next. And then as I got information, I sort of immediately put it to use. Labeled it as I went so that I was sure about what I had. At least up to a point. I'm a little bit sloppy here, but this should have been like total earned if I needed to write that, but I didn't feel like I needed to write it in that moment. It is good to stay organized. That doesn't look like the word earned anymore, but you get what I mean. And then this was 10% here. And remember that the nice thing here is like if you don't have a calculator, 90% means just get rid of 10%. 10% is easy. You just move the decimal point over. Right? So cool. Let's move on to the next question, but notice I used the answer choices and I didn't get bogged down in the reading because I read actively starting at the end of the question. Okay, I think this is 9. Okay, so look at this massive stack of information. Let's go to the end here. Which of the following systems of equations represents the conditions described if X is juniors? Look down here. Okay, this thing about 3s. And Y is seniors. Okay, cool. Let's work backwards. This sentence says she must hire at least 3 juniors and at least 1 senior. At least. So 4 would be cool for juniors. Right? At least 3. 2 would not be cool. So, look, I can get rid of C. Let me get rid of these check marks just to save some space. I can get rid of C because it's saying less than 3. But you need 3 or more. Now, this language about at least can be confusing because then we're like, less, least, yay. But no, think about this in terms of real numbers. Like 4 juniors would be cool, 2 would be uncool. At least 3. Okay, so 2 is in this category, so this one's out. And same thing down here. So we've gotten rid of 2 answers. And the Y's look cool for A and B, right? They're saying the same, more than 1 or more, at least 1, right? So that language, just be aware of the fact that language like at least can be a little bit misleading. You really still have to synthesize this information. That's why I'll say things like more than 3 or more, right? Just changing that language, it means the exact same thing, but it helps me feel like I own that information. Okay, cool. So like then there's this like information in the sentence above. If I want, I'll just grab it. Her budget for paying staff members is no more than 9.7. Okay, so no more than that amount. Well, look, both these answers say the same. Oh, no, they don't. They have these different signs. Okay. Well, I guess my next question is then what do these numbers 640 and 880 represent? So you go searching for those. 640 per week for the juniors, 880 for the seniors. Okay. So this is the amount that she's paying folks, 640 times the number of juniors, 880 times the number of seniors. And she can't pay more than 970. So the amount she pays must be, at max, I should say 9,700, right? So I think this is out and I think this is right. Now, I could confirm this because there is a difference between the signs in the second equation. So is this group bigger than 10 or less than 10? she has to have at least 10. So 11's cool, 9 is not cool. So by using real numbers, I can feel very clear, like, okay, B says 11 total people would be cool. A says you need 9 or 10 or less, right? So just by using the answer choices and asking myself small questions and being very tangible with that information. So don't repeat information the exact same way you read it. Synthesize it by changing the language slightly. Then you own the information. Then you understand something. Right? So be active. That's like my best advice about learning, generally speaking, is be as active as you can in that process. Don't let anything be automatic. Okay. So that's number 9. Let's keep going. And again, I would love any pushback that you have for me. Anything you feel like I'm saying that you disagree with, let's talk about it. Because I don't know everything by any means. But I do have some ideas about this stuff. And even... I welcome the idea that we could discuss this and figure out if there's a better way to do it, for sure. So the equation has these 3 roots. Which of the following is a factor? Okay, so all you have to know is what roots do relative to factors. Like, if you have a root at -1, it means x plus 1. And this means x plus 3, the -3, and then this 5 means x minus 5. Like, that's what this equation means. It may be that there's more factors to this equation, but essentially, whatever else happens, which there isn't because it's x cubed. But let's pretend that there was a whole bunch of other stuff out here. It wouldn't matter because whatever times if x is -1, the whole thing's 0. What does a root really mean then? If you are still unsure, and if my explanation has been a little unsure, it means spots on the graph where the equation crosses the x-axis, where the value of y, or f of x, value of f or y, the vertical component of your graph, that value is 0. We're at the ground level, you might say, which is the root of the function. So x plus 1, x plus 3, x minus 5. We only have one of those. One more thing I could say about this. Look, if you didn't know, and even if you do know, you can learn from multiple choice here. Look, if the logic is x minus 1, so, if -1, so x minus 1, right? If you want to match those up, then why aren't there other 2 answers that are also correct? Right? So in a sense, the design of this question gives away the answer. If there's only one right answer, then it must be the one that breaks the pattern of the other 3 answers, right? If you think x minus 1 is right because of -1, then you have to concede that x minus 3 would be right because it has a -3. At least if you're thinking about it, the way I am. Okay, hope that's helpful. Let's keep going. Knowing what roots are is huge. The other way that they'll talk about it is they'll call it zeros. A 0 is the same thing as a root. All right, 2 for 1 here. I just put 11 and 12 together because I am lazy. All right, so this number 11 is about just knowing some rules. So keep calm and just follow the rules here. Negative exponents, go from numerator to denominator or denominator to numerator. They flip is one way of saying it. So that x squared comes down here. X to the 1/3. You could write it as x to the 1/3. You could also write it as the cube root. So let me write it as the cube root here. 3x. Now, again, there's other ways of writing it. And you could combine these two, right? But I'm just seeing in the answer choices that, like, this thing's here, d. So I'm pretty sure that's right. So one thing I should have said right at the beginning is I'm looking at the answer choices to notice how they want the answers. Because let me say this while I'm at it. I could write this as x squared times x to the 1/3, and then I could rewrite that as a denominator that says, like, add those two together. So x to either the 2 1/3, so you'd probably write that as 7/3. 2 is 6/3, so an extra third would be a 7/3. That is, you add them once you have the same base. If you have the base is the same, then you add these exponents of 2 1/3. So you could write it as 7/3. I just didn't see an answer that looked like that. So I went with our other way, right? So that's why I said the cube root of x. Okay, so I'm pretty sure it's d, but let's finish this problem out. the y to the negative 1, this is going to move up the same way the x to the negative 2 moved down. So negatives are ways of writing reciprocals. So you got y to the 1, you got y to the 1/2, which similar to what happened with our cubed root, it's just a 2 cubed root y. Cubed root, square root, sorry, I misspoke, but I wrote it correctly. The square root. Right? And, this 2 can be left out. It's implied, and that's what the answer choice does. It just has the normal square root. The 2 is just clarifying that we're talking about a second root, which is unnecessary, but just so that you can see the relationship between cube and square root. By the way, just for fun, let's just notice what happens if you have like y to the 7, over 3. I guess we had x to the 7/3. Let's use that. X to the 7/3 could also be written as the third root of x to the 7. That is to say, you can move the denominator, just like the denominators for the 3 and the 2 up here turned into roots. The denominator of x to the 7/3, the 3 becomes a root. The 7 stays as an exponent. It's a related rule. So negatives flip, fractions are roots. Those are the two things you got to know for that question. All right, number 12. Which of the following intervals contains the x-coordinate of the vertex of the graph? Okay, so knowing something important about parabolas here. If you have a parabola and you have these two roots, so I'll try to draw it a little bit bigger here. X plus 3, so that means again negative 3, and x plus 1 means negative 1. Those are values when this thing equals 0, right? Because think about it. These are spots when if you put a negative 3 or a negative 1 in either of these spots, the whole thing is going to equal 0. Doesn't matter what happens in the other spot. If negative 3 goes here, doesn't matter that over here it would be negative 3 plus 1. You get 0 times that amount, right? So these things reflect spots where the graph hits 0, like we already talked about. Parabolas are always symmetrical, you might notice. So, this parabola ends up opening up because if we were to FOIL it out, we'd get x squared plus 3x plus 1x, so plus 4x plus 3. This graph would then mean that this spot would be like 3, so my scale's way off. But the point is, this would be the y-intercept. The fact that x squared, the a term here, and ax squared plus bx plus c, right? C is 3, that's the y-intercept. And the a term, which is an implied 1, means that the graph opens up. It's positive and not very steep. That's what it means. But all of that aside, the really important thing is knowing that halfway down the middle is the x-coordinate of the vertex. The x-coordinate of the vertex is halfway between the roots because it has to be. If this thing's symmetrical, then it has to do the same things from its starting place as it goes up, right? So it's between negative 3 and negative 1. And be careful about, make sure you could actually tell yourself that it's exactly negative 2. And that would be a really good way to ground your thinking and be like, okay, negative 2 is not between these other things. Because inequalities, it's really easy to mess up, especially with negative signs, right? Because for instance, negative 5 x 0. Sometimes it's weird to think about negatives, or even this situation with one being, negative 1 being greater than negative 5 can be kind of tricky. I know it sounds stupid to make that mistake, but we all make silly mistakes, so I try to be extremely grounded, use real numbers every chance I get to confirm what my instincts are telling me. Okay, so let's see where we're at. That was 12, here's 13. Okay, great example of a question where using real numbers is very, very helpful. So, on this question, you could use polynomial division. That's what they want you to do. But I wouldn't do it because I'm kind of a punk like that. I would try x equals 0 first. If I want to be a real punk about it, I could try x equals 1. It'd probably be a little safer. But just to be a total punk, let's see what happens when x equals 0. Well, the top becomes negative 5. The bottom becomes negative 3. The negative signs cancel. We get 5/3 when x is 0. Okay. Well, I guess I'll try out these answers. The nice thing is the math doesn't have to happen over and over again. X minus 5, that's, answer choice A is saying negative 5 minus 20 over negative 3. Now, even if you don't feel like, okay, that's some complicated maybe math if you want to change the signs if you want. But even if as long as you know that 20 over 3 isn't equal to positive 5, then you're done. Right? Like, you need to get to 0. So you need these things to cancel. The same thing with b. Like, you would get x equals 0, so negative 5 minus 10 negative thirds. So, I mean, cool, we're adding 10 thirds, but 10 thirds doesn't get us back to 0. So c would say 1 minus 8 over negative 3. So I'm starting to get the sense that I might have done this question wrong. I am. I totally did, because I forgot I was looking to get to 5/3. So my apologies. Let me back up and say I need to get to 5/3. So 5/3 is a positive value. I can still get rid of b. So my apologies. B is wrong because I know I'm not adding enough to get to a positive value. A is going to add, let's see, what is 20/3 equal to? I guess that's equal to 6 2/3. So negative 5 and 6 2/3, that would get us 1 2/3. And that's exactly what 5/3 is. So it is answer choice A. My mistake. You could confirm if you were feeling a little shaky about my math. I wouldn't blame you. Negative 8. So this answer is going to be too big because we're trying to get to something that's between 1 and 2, right? 5 over 3 is between 1 and 2, and this is more than 2. And then answer choice D was going to give us, what, 1 and then plus 2/3. Okay, so that answer worked as well. So this is what I mean about when you pick real numbers, you may... I've made a real mess of this question, but I'm going to finish it out. I think you can learn from the mess that I just made. But the bottom line is I tried x equals 0 and I got it down to 2 answers, right? So it wasn't a complete failure in that way. If I want to make sure I totally avoid this mistake or this situation happening again, then pick a big and easy number, right? So I'll pick x equals 10. That's a big, easy number. So x squared is 100 minus 2x, so that's 20, and then minus 5. Okay, so that's 75 on top. On the bottom, we're going to get 7. 10 minus 3. Okay, so negative 75%. Look, that's really close to negative 11. It's a little bit less than negative 11. Or a little bit greater. See, that's what I mean about... It's negative 11-ish. Let's just see if that's close enough to get rid of one of these two answers. So A is saying, what? X minus 5. Okay, so that's 5. Answer choice A says 5 minus 20 over, I guess, 7. So I don't think so. And I totally think I messed this up again because this is totally positive 11. Train wreck. But I still don't think that this is going to give us what we want. And answer choice D, which gives us 11 minus a little tiny bit, which is 2/7. This is totally right. Okay, so I weathered the storm there. I apologize for the confusion, some sloppy math at times. However, by using values, I was able to work through a difficult question, and the only mistakes I made were kind of silly mistakes that I could have avoided by being absolutely explicit about these as the things I'm searching for. Right? So, at the risk of bogging you down completely, I am going to show you the other way of doing this, because if you know polynomial division, it might be faster than what I just did. So let me show you that. Here we go. Polynomial division is simple if you know it. If you don't know it, use real numbers and try to avoid the silly mistakes that I just made. But polynomial division looks like this. All you have to worry about is the leading term. So x squared. How many times does x go into x squared? Well, x times x would get you x squared. So there we go. Now, on the way down, we multiply not just by the leading term, but by everything. And we subtract that difference to see what's left. X squared minus x squared, by design, that should cancel. Negative 2 minus negative 3, which ends up being positive 3, means that we're up to 1x. And then we bring this negative 5 down because nothing has been subtracted from that. Now we say how many times does x minus 3 go into, or how many times, again, with leading terms x and x, of course, goes in once. We see what's left when we multiply that 1 down. Of course, we get x and also 3. That is by multiplying 1 times everything. So on the way up, you just worry about the leading term. On the way down, you multiply times everything. What do we get left over here? Of course, the x's cancel, again, by design, x minus x. Negative 5 plus 3 is what that works out to, which is negative 2. That's our remainder because x minus 3 doesn't go into negative 2. So we get x plus 1 with a remainder of negative 2. Okay. So if you know how to do that, that's simple enough and easy to do. I will say if I had just, worked with a number like 10 from the get-go, I probably would have gotten rid of all my answers. I chose to be a little bit of a punk by using a 0. You could also try using a 1 if you wanted. Those are both sort of punk ways that could lead to some trouble, but it also could get rid of some answer choices quickly if you avoid the silly mistakes that I made. Okay, cool. So moving on to number 14. Let's see. Here we are. Okay, word problem with inequalities. Let's read this last sentence. If a box has a height of 60, so I'm going to extract information as I go. Height is 60, length is 2.5 times the width. 2.5w, which inequality shows the allowable width, x. So x equals the width. Okay. So I don't know what to do with any of these. I suppose what I could do if I wanted to move efficiently is to pick a number in between 11 and 2/3 and 17. Right? Because look, if I pick something like x equals 15, I'm going to have to say multiply by 2.5. So let's make x equal something a little bit easier to work with, maybe like 12. Look, if x equals 12, then A and B are wrong answers, right? Because if x equals 12 works, then you can't put a limit below 12. If x equals 12 does not work, then we get rid of two answers as well. Because if x can't exceed 12, if x can't be 12, then it certainly can't be 17 or 19 or 20. So I'm going to try that number as a starting place, and I'm just going to put it into this situation and then see what information. I haven't read all this other stuff yet. I know there's more information, but let me just start here. Like, if the width is x, so x, which if we're using 12, if x equals 12, then we'd say something like, I'll put this up here. If x equals 12, that's the width. And then the length is 2.5 times the width. 2 times 12 is 24. Another half is 6. So that would be 30. Okay, let's see what happens up here. Shaped like rectangular prisms, that's a box. The sum of the perimeter of the base of the box. And then the height. Oh yeah, we already have the height. Okay, cool. So the perimeter of the base would just be length times width, right? So that's just like 30s and 12s. I know that doesn't look like 30s and 12s, but I'm trying to just do it as if I were doing it on the test. So this perimeter here is what, 84 if x equals 12, right? We have 60 and 24, so 84. And then we have to add the 60, and it can't get above 130. Well, 84 plus 60 is going to get us above 130. Okay, so I've crossed off these two answers. 12 was too big. So I guess I'll try 11 and 2/3. But I'm not going to try that fancy number. Let me just try x equals 11. For the same reason, if 11 works, then A is out. If 11 does not work, then B is out. Because if you don't understand that, pause and think about it for a second. X equals 11 would mean that answer choice A doesn't cover all of our options, right? Likewise, if x equals 11 does not work, then one of the options in B, which is 11, does not work, and therefore B is not right. So let's try x equals 11. Okay, so that's the width is 11. The length is 2.5 times that, which is kind of a pain, I know, but that's 22 plus 5.5. So that's 27.5. 22 and 5.5. So similar, I'll draw another bad box. So the last one I have to draw. So 27.5, 11, a couple of groups of each of those, or a group, a couple components of each of these. Set 27.5, that's going to be 53 plus another 22. So that's plus 22. And that's equal to 75. And this is the kind of stuff that, because you don't have a calculator for this set, like I think I just already caught a mistake that I just made. I think this is 55 plus 22, which is 77. So like take your time with that part. That's the hardest part, is making sure that you've done this calculation effectively. Right? 11 was kind of a pain in the butt, but 2.5 times 11 is 22 plus another 5.5, so 27.5. And then two groups of 27.5. The way I just checked my work and saw that I made a mistake was that two groups of 25 is 50, and then two groups of 2.5 is 5. Right? So that's 77. Okay, cool. So 77 and 60 is more than 130. Right? Because 70 and 60 is 130. So it must be A. That would be the best way to do it. And if you want to confirm that this makes sense, I mean, trying out 10 doesn't actually confirm that A is right, because 10 is an option in each answer choice, right? So, I mean, you could double check with other numbers if you wanted, right? Like if you wanted, you could use, I guess, actually use 11 and 2/3. That seems kind of crazy though. I wouldn't do that. Okay, so I hope that's helpful. Let's move on to the next question here. Notice, I think the thing to learn from that last question, as I'm pulling the next one up here, is that once again, I tried to break the question into components and work with those smaller components. Like, don't try to read the whole thing all at once. What is the value of K? They're asking. Okay. Well, I think I would just try these numbers out. I know that this is a difference of squares, right? So that's a really important idea on this test. So let's make sure we're cool with that. We should notice that when we FOIL this out, the outside term is positive kx and the inside is negative kx, and those will cancel. So we get x squared minus k squared. It's still multiplied by 1/3 though. So x squared minus k squared times 1/3, 1/3 x squared minus 1/3 k squared. Okay, and we're going to end up with this. So -2 must equal negative 1/3 k squared. So 2 equals 1/3 k squared. And at that point, we just have some simple algebra to do. Multiply by 3, we get 6 equals k squared, and k equals √6. I said I was just going to try out the numbers, but once I started thinking about difference of squares, it didn't feel like the right move to just try out these numbers. But you totally could. You could just, if you knew that information and you didn't have to write it out, you could be like, okay, well, look, if I use a 6, then I know I'm going to get x squared minus 36, and then I'm multiplying that by 1/3. And that's not going to get me -2. Okay, so that's out, right? If I try a 2, it's going to give me 1/3, and then this is going to be a 4, and that's not going to work. If I try out √2, it's going to give me a 2, and that's not going to work. If I try out √6, it's going to give me a 6 when I do the math here. That is, if I try out these answer choices in the place of k, you know, because of the difference of squares, that you're just going to end up with this guy, x squared minus k squared. Right? So whatever our value of k is, it just ends up here when it's squared. Okay, cool. So best way to do that question is to try out numbers if you need to, but really it's about knowing this thing about difference of squares. X minus k, x plus k, those are conjugates, and they get multiplied together to be the difference of squares, x squared minus k squared. All right, so I think we only got a couple more to talk about here. 17 And then looks like 17, 19, and 20 we're going to talk about. So skipped a couple. Okay, so the reason I wanted to talk about this question is because it's a great example of how you can just kind of like plug away on some stuff. Like this is 120 because that's a straight line. This is 50 because a triangle must add up to 180. So 60, 70, and 50. You know, this one's 60 because two lines that intersect will have opposite angles that are equal. And then they tell us that MP and PR are equal, which means that the remaining degrees for the triangle MPR, that must be split evenly, which means the remaining 60 degrees turn into a couple of 30-degree angles. 120 plus 30 plus 30 for 180. And all they wanted to know was QMR, which was this 30 degrees, right? So my point is, like, if you don't know what else to do on a geometry question, just start filling in some stuff. It's always about triangles adding up to 180 and straight lines adding up to 180. And things like isosceles, triangles have two equal angles, right? Okay. So yeah, geometry, and oftentimes I see people say, I don't know how to start this question. It's like, just start it. Just do something, and you'll see that the geometry is usually just a matter of dominoes, like falling into place. You figure out one thing and it leads to another thing, and so on. Okay, so for 19, there's two things I wanted to say about this question. Number one is that you could like just use a very standard approach, which is to say, figure out the slope. Now, when I figure out slope, I do stuff like this: 4 over 1 minus 0 over 2. So what I just did is I intentionally put in both points or both coordinates of one of my points, then intentionally put in two minus signs, and then put in the y and the x from the other point. So that was a way for me to avoid the mistake of getting mixed up with which numbers go where. It's just being a little bit more intentional. Instead of saying y2 minus y1, it's like put in the y, put in the x. Minus, put in the y, put in the x. Right? That approach to me is a little bit... It's just different, which means that I won't make the same mistakes. And obviously what we get here, 1 minus 2 is negative 1. So the slope is negative 4. So what we got so far is y equals negative 4x plus b. And we could just put in the values here. So like when x equals 2, y equals 0. That's negative 8 plus b. So b is going to be 8. And if you want to confirm that with the other point, try y equals 4, x equals 1, right? Still plus b. So this is the same thing with different points. And this will also give us b equals 8. So that's the final form of our equation, y equals negative 4x, and then plus 8. So the other way you could do this, if you wanted, is you could say, well, these points 1, 4 and 2, 0 show us that when we go down 4 units to go over 1. So let's go backwards 1 unit and up 4 units. That would be the other way. And I think I would do both, honestly, if I have time, because I feel like I won't make the same mistake twice if I do it that way. It's very easy to make a mistake on a question like that and feel confident. It's harder to make the same mistake 2 different ways. So if you have time, that would be the way to do it. Number 20, what is the value of a plus b? So it looks like we've just got to combine a bunch of terms here and be careful about what happens when we distribute. So I'm going to rewrite this thing. This is 10 times 10y squared is 100 y squared, and then 10 times negative 110. So that's what we really have. There's nothing else that changes. So we get 2 groups of y squared. One of them is 100 and the other one is another 100, so that's 200y squared. And then we've got to combine 7532 and negative 1100, which is 6432. And then we want to add these two things together, which gets us 6632. So as I see that question, I'm thinking to myself, all right, as long as you distribute correctly and as long as you're careful with your calculation, you're going to get this right. So be on high alert for calculative mistakes. Be on high alert for sign errors. Right? So as long as I didn't make a sign error, and I'm double checking my math by in reverse saying, okay, 6432. What if I added 1,100? That would give me 7,532. Perfect. Okay, and we got two groups of 100y squared. If we're just adding a and b, that's 200 plus the 6432. Cool, got it. Right. So notice as I'm checking my work, I'm doing things as differently as I can imagine doing them in a situation like that, so that I probably won't make the exact same mistake if I do things in different ways. Okay, cool. That's the calculator section. Certainly there were some other questions earlier that we skipped, and I'm happy to talk about those, but these should hopefully be useful for almost any student who made any mistakes in this section. Probably one of these questions will apply to you. So I hope you learned a thing or two, and I hope you took some good notes. If you're meeting with me on a weekly basis, what I would want is for you to come to the lesson with notes and questions about what you've seen so far. So if you got to review some stuff, I want you to feel like you understand the questions well enough to teach them to me. So work on that, and hopefully I'll see you soon. Thanks. Take care.